All right, let's revisit now that we have a bunch of tools in our toolbox as far as all of our formulas go. Let's look at a couple more of examples of verifying and proving identities and formulas. The first one is going to be very direct and a little more simple. The other two, one will be a lot more involved. But notice, look at this problem. Verify that the cosine squared of 5x minus sine squared of 5x equals cosine of x. Now, if you look at your formulas for double angle formulas, notice that the cosine of 2u, 2 times an angle, one of the forms of it is cosine squared of the angle minus sine squared of the angle. I could actually use this couple directions here. Notice right here, I have cosine squared of an angle minus sine squared of an angle. So I can use, so I'm going to start here. So I'm going to start with cosine squared of 5x minus sine squared 5x. And I'm going to work towards this as being my goal. Well, based on our double angle formula, our double angle formula, this is the same thing as the cosine of 2 times that angle that's inside. And that's the cosine of 10x, which is our goal of cosine of 10x. That identity is verified. So we're still going to start the same way we did before, where we pick a side, we work with it, and work towards the other side. And I could have just as easily started with the cosine of 10x and morphed it the other direction and have done that as well. The next couple of problems I do aren't going to be quite as straightforward as the one we just had. Let's look at this guy. All of these are from our homework for this section. And for this one, I have the tangent of x over 2 plus the cosine of x times the tangent of x over 2 equals the sine of x. When we are verifying and proving identities, we always pick a side that we can work the most with and try to get it to the other side. Well, if we look at this one, this left side is definitely a lot messier. It has the most to work with. So this is where I'm going to start. And I'm going to try to work with my identities, my formulas, to reach my goal of just having a sine of x. One is definitely easier than the other. So I'm going to start here. I have tangent of x over 2 plus cosine of x times tangent of x over 2. Now, notice in my goal, the angle is just an x, so I don't want any x over 2's in there anywhere. Now, we do have a formula that says, we actually have two formulas for half angle. The tangent of an angle over 2 is 1 minus cosine of the angle over sine of the angle, or tangent of the angle over 2 is sine of the angle over 1 plus cosine of the angle. I'm going to go ahead and just use the first one. Tangent of x over 2 using the formula. So I'm looking at my half angle formula. Tangent of x over 2 is 1 minus the cosine of x over the sine of x. My part of my addition here that has cosine already has the angle we want. Tangent, I'm going to use the same thing, 1 minus cosine of x over sine of x. And let's do a little simplifying here. This is 1 minus cosine of x over sine of x, plus, if we multiply, that's like over 1, so I'm going to multiply. Cosine of x times this is cosine of x minus cosine times cosine is cosine squared over sine of x. Now remember, my goal is sine of x. It's a single term, so I need to do something to get these terms together. I'm going to go ahead and add my fractions because we have a common denominator. So I can keep the sine of x, and I have 1 minus cosine of x plus cosine of x minus sine or cosine squared of x. Negative cosine of x plus cosine of x cancel out. And that's 1 minus cosine squared of x over sine of x. Now remember, always look towards your goal. We're trying to get to sine of x. You may notice, and hopefully you're already starting to notice, that you're getting closer, because what is 1 minus cosine squared? This is one of our Pythagorean identities. 1 minus cosine squared is the sine squared of x. So we have sine squared of x over sine of x. So one of our sines will cancel, and that leaves us with sine of x. So we simplified. At that point, I just simplified. And notice that did equal my goal, which was the sine of x. This identity, or this formula, has been verified. That mess was actually just sine of x. So you can, all those identities we had, all of those formulas we've had so far, we can use to help simplify what we have going on. Okay? Let's look at one more verify problem. Let's verify that 2 times the tangent of x over 1 plus tangent squared of x is equal to the sine of 2x. Now, when we look at this one, that left side, the 2 times tangent of x over 1 plus tangent squared of x, looks really familiar, but it's a little bit different. Notice on your formulas, 2 tangent of x over 1 minus tangent squared of x would be tangent of 2x, but there's a minus there. In the problem we have here, there's a plus. So it's not quite one of the formulas from our sheet there. Remember, you can start with either side and work your way there, okay? I'm going to go ahead for this one, and I'm going to start here because I have a formula for double angle of sine, and I'm actually going to make this messy side be my goal. You can start with either side, but I'm going to go ahead and start with the sine of 2x, okay? And I'm going to work with this side. Formula, our double angle formula, sine of 2x is 2 times the sine of x times the cosine of x, okay? It's not a fraction, right? Remember, tangent is sine over cosine. I can think of this as being 2 times the sine of x times the cosine of x over 1. Here's where I'm going to use the fact that I'm trying to get to tangent to this fraction. I have a 2 up top. That's good, okay? But I need a tangent up top. And right now I have a sine and a cosine. Tangent is sine of x over cosine of x. So I need to do something to end up with a sine of x over cosine of x on the top. You know what I'm going to do? I am going to divide this numerator by cosine squared of x. Why cosine squared? Because I have a cosine here. So one cosine will cancel out, but I still want to have a cosine on the bottom to get to my tangent. So I'm going to divide by 2 cosines of cosine squared of x. So what do I have here? Up top, that gives me 2 sine of x cosine of x over cosine squared x. I'm putting every little step in here. Over 1 over cosine squared of x. That is, one of the cosines will cancel. That is a 2 sine of x over cosine of x. That's getting me closer to that numerator. That's going to give me the tangent. okay? 1 over cosine squared, what's the reciprocal of cosine? Secant. So that's secant squared. Okay, remember my goal. I'm trying to get a 1 plus tangent squared. I have a secant squared. Look at your identities. Think about the identities that hopefully you've been memorizing. We have a Pythagorean identity. It was in our very first section of this unit here. We have a Pythagorean identity that says 1 plus tangent squared of an angle is equal to secant squared of an angle. I have secant squared. So that means that's actually the same as 1 plus tangent squared of the angle. Aha! That does end up giving us what we had. Our identity has been verified. The way that I worked through that one is a way that you can use the idea that keep the goal in mind, what you have to work with, what you want to work with. You could have worked with that left side and tried to get it to the right side, knowing that the sine of 2x was 2 times sine times cosine. We could have totally worked with the left side. Let me do that. Let me do that. Let's look. Same problem. I want to verify that 2 times the tangent of x over 1 plus tangent of squared of x is sine of 2x. Now I'm going to try it the other way. I'm going to start over here, and I'm going to make this my goal, because it doesn't matter. And we all think a little bit differently. Okay. So we all might start tackling it differently. There are a few things that we can do here. First of all, 1 plus tangent squared x. Based on one of our Pythagorean identities, that is secant squared x. So this is the same as 2 times the tangent of x over the secant squared of x. Remember, all trig functions can always be put in the form of sine and cosine. So if you want to, and we know that we're heading towards sine in the end, so if you want to, go ahead and use your reciprocal identities here, or your quotient identities, your reciprocal identities. Tangent is sine over cosine. So this is 2 sine of x over cosine of x over secant squared is the reciprocal of cosine. So that's 1 over cosine squared of x. We have a fraction within a fraction. So take your common denominator. Your common denominator for those two little fractions is cosine squared of x. So I'm going to multiply both the top and the bottom by cosine squared of x. And so up top, one of my cosines cancel. That gives me 2 sine of x cosine of x. On the bottom, those cancel. That's just a 1. Remember, this is our goal. Look at what I have here. The sine of 2x is 2 times sine of x cosine of x. I'm getting right to my goal here, because this is the same as 2 sine of x cosine of x, and based on our double angle formula, that's the sine of 2x, which was our goal. Identity verified. So you can absolutely work from either side, and one side may be easier than the other. It just depends on what you have going on. So there we go. Go ahead, try your homework, see what questions you're having. In our first 3 sections that we've talked about in our first few videos in Unit 3 that we've been dealing with so far, it's all been using our identities, using our formulas, evaluating for exact values, a lot of verifying. So practice, 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 practice. You're verifying, okay? In the next couple of sections, we're going to change from just working with expressions, and we're actually going to solve trig equations. So being able to simplify using our formulas and our identities is going to help us out when it comes to solving equations as well. Okay, so try your homework. Yell if you have any questions. Thanks.